Welcome everyone. We will be continuing with integration by parts examples. Our first example is integral of arctan of x dx. U is going to be arctan of x, and from calculus 1, I know that when I differentiate this function, I get 1 over 1 plus x squared dx. dv is going to be dx, and v is going to be x when I integrate both sides. Now I just follow my arrows, x arc 10x minus integral of x over 1 plus x squared dx. 1 plus x squared dx. To solve this integral, to integrate this, I need to do one more substitution. 1 plus x squared is equal to z. Differentiate both sides. 2x dx is equal to dz, and dz is equal to dx is equal to dz over 2x. X arc tan of x minus integral x over z dz over 2x. Cancel the x's out. This gives me x arc 10x minus 1 half ln absolute value of z, but of course I define z, so I will write 1 plus x squared plus c. My second example, integral square root of x squared plus a squared dx. Normally, we have other methods to solve this integral, but let's stick with integration by parts. In calculus 1, I taught you guys that if I want to differentiate a square root, what I can do is differentiate inside, and this is over 2 itself, 2 times itself. So this will be differentiate inside 2x over 2 square root of x squared plus a squared dx. dv is going to be dx, so v is going to be x. Follow the arrows. X square root of x squared plus a squared minus integral, I can cancel these 2's, x squared over square root of x squared plus a squared dx. How am I going to integrate this? I will do a little change inside the integral, which will be adding the term a squared and subtracting it again, so I don't change anything. This is over x squared, square root of x squared plus a squared dx. Why did I do this? Because now I can write this as square root of x squared plus a squared minus integral of x squared plus a squared over square root of x squared plus a squared dx. There's a negative sign here as well, so it will be plus. I can take the a squared out. A squared integral 1 over square root of x squared plus a squared dx. I already know the answer of this answer. To be remembered, it was ln absolute value of x plus square root of x squared plus a squared. And for the left side, I need to see that this is equal to square root of x squared plus a squared dx. If you didn't understand why, we can write this as to the power of 1 half, but this is to the power of 1, so subtract it. When you subtract it, you get 1 half again, so it's square root of x squared plus a squared. Plus ln absolute value of x plus square root of x squared plus a squared. Now this is easy to solve. This is not easy to solve, but what we have is, this is the same integral we had here, so if I call this I, and this will be equal to I, and this is also equal to I, so if I add it to the both sides, 2I is equal to x square root of x squared plus a squared plus ln absolute value of x plus square root of x squared plus a squared. And the last step is going to be dividing both sides with 2, obviously, plus ln absolute value of x plus square root of x squared plus a squared. This is over 2 plus c is my answer. Our third example, we are missing an integral sign. Let's add it. Integral e to the x sine of x dx. U is going to be ILATE. Since trigonometric is before exponential, U is sine of x and du is going to be cosine of x dx. dv is equal to e to the x dx. V is equal to x. Follow the arrows. This is e to the x. Why did I write x? V is equal to e to the x. Follow the arrows. E to the x sine x minus integral e to the x cosine of x dx. As we expected, we have another integration by parts. Why do we expect it? Because we did something really similar to this in our previous video. U is going to be cosine of x this time. Du is going to be negative sine of x dx. dv is going to be e to the x dx. And v is going to be e to the x. Follow the arrows, but before that, let's write this part, e to the x sine x minus e to the x cosine of x minus, there's another negative sign, so it will be plus, integral e to the x sine x dx. This is the same integral. I will call this integral I. So I is equal to e to the x sine x minus e to the x cosine of x plus I minus I, because there's a negative sign here. When I add I to the both sides, 2I is equal to e to the x by sine x minus cosine x. Of course, we will divide it with 2. I is equal to e to the x sine x minus cosine of x over 2 plus c. Integral of cosine of ln of x dx. If I say u is equal to ln of x, 1 over x is equal to du, 1 over x dx is equal to du, dx is equal to x du, nothing happens. So I will have to use integration by parts again. And du is going to be negative sine of ln of x over x dx. Why? Because first I differentiate the outside and I differentiate the inside. ln of x differentiated is 1 over x. dv is equal to dx, v is equal to x. Follow the arrows. X cosine of ln x minus integral. There's also a negative sign, so plus integral sine of ln of x dx. You should be seeing where this is going already because I will apply integration by parts one more time and it will give me the first integral again. Let's do it here. U is going to be sine of ln x. Du is going to be cosine of ln x over x. dv is dx, v is x. uv v du, x cosine of ln x plus x sine of ln x minus integral of cosine of ln x dx, which is the first integral. So I is equal to, I will not write it, I will just add I to the both sides. 2I is equal to x cosine of ln x plus x sine of ln x. I is equal to cosine of ln x plus sine of ln x over 2 plus c. Integral of arc sine x over square root of 1 plus x dx. Nice integral. Of course, we will be doing integration by parts again. ILATE. I have a function that includes arc, which means inverse, right? So u is going to be arc sine x. And differentiating this gives us 1 over square root of 1 minus x squared dx. dv is going to be 1 over square root of 1 plus x dx. From here, v is going to be 1 plus x is equal to u, du is equal to dx, square root of u, u to the power of negative 1 half. So this gives me 2 square root of 1 plus x when I integrate both sides. Follow the arrows, uv, v du. This becomes 2 square root of 1 plus x arc sine x minus integral. Yeah, I don't like where this is going, but let's see if we can do some more simplifications. Square dx. Now, what can we do for this integral? Let's see, there's a square root of 1 plus x over. Alright, what we can do is 2 by square root of 1 plus x arc sine x minus integral. I will take the 2 out of it. 1 plus x. Instead of square root of 1 minus x squared, I will use a squared minus b squared is equal to a minus b by a plus b. So this becomes square root of 1 plus x by square root of 1 minus x dx. Cancel these out. This is now really easy to solve, but let's write it one more time. 2 square root of 1 plus x arc sine x minus 2 integral 1 over square root of 1 over 1 square root of 1 minus x dx. Good. Now 1 minus x is equal to u. Negative dx is equal to du. So does this become 4 or negative dx is du? So 2, that is negative, so this is also negative, so it has to be positive, so which is equal to 2 square root of 1 plus x arc sine of x plus 4 square root of 1 minus x plus c. Our last example in this video, integral x ln of x squared plus 1 dx. Of course, ILATE. And I have a logarithmic function, so u is going to be ln of x squared plus 1. Differentiate both sides. How do I differentiate ln of x squared plus 1? Inside of it differentiated over inside of it itself, dx. dv is going to be x dx, so v is going to be x squared over 2. Follow the arrows. X squared ln of x squared plus 1 over 2 minus integral of 2's will cancel each out, x cubed over x squared plus 1 dx. Since the degrees are not the same, but if the numerator has a greater degree than the denominator, I have to do polynomial division. There's no other way to solve this integral now. Let's do the division. X cubed plus x. I will do it until the degrees match and negative x. So this can be written as x squared ln of x squared plus 1 over 2 minus integral x minus x over x squared plus 1 dx. Let's make sure this is correct. X cubed plus x, so x cubed plus x minus x, so x cubed over x squared plus 1, so which is correct. Now this is really easy to solve, right? X squared ln of x squared plus 1 over 2 minus integral of x dx plus integral of x over x squared plus 1 dx, which is x squared ln of x squared plus 1 over 2 minus x squared over 2 plus I need to do one more substitution. X squared plus 1 is equal to z substitution. dz is equal to 2x dx. The reason I use z is I used u here once, so I don't want to create some confusion between those u's. Alright, dz is 2x dx. I can cancel the x's out. So basically, 1/2 ln absolute value of z, which is ln absolute value of x squared plus 1 plus c is my answer.